This question, and basically whenever you see something like this where it just directly asks you for a limit and there's some function in here, you want to see what's happening slowly, but you can already start to guess maybe that you're going to be doing algebra. But what really gives it away is that you have this 0 over 0 form. -4 as x approaches -4 on the top, you're getting closer and closer to 0. And as x approaches -4 on the bottom, -4 cubed is -64, and then minus 16 times -4 is going to be positive 64. So this is going to get closer and closer to 0 as well. That 0 over 0 case, and you see that there's some, that this is a rational function where algebra might be able to be done. That kind of gives it away that you want to do algebra. Now, it could be that you could do L'Hopital's rule and get the limit, and I think that would work as 0 over 0 form. So what would you get? You get 1 over, if I did L'Hopital's rule, I'm just testing this because I actually want to see if this works. And then now the discontinuity is removed, and this is a rational function. -4, does that give me -4 squared is 16 times 3, 16, yeah, -4 is 16. 16 can factor out. 3 minus 16. 16 can factor out. Oh, 3 minus 2 is 2. 32. 1 over 32. Oh, cool. Yeah. So we could do L'Hopital's rule and get the right answer, but I mean, you don't have to. It is in the L'Hopital's form. It's 0 over 0. So you can differentiate the top. The derivative of the top is 1. Over the derivative of the bottom is 3x squared minus 16, and then you could evaluate the limit as x goes to -4, and you'll find out that this bottom part, the top part stays fixed at 1, but the bottom part is getting closer and closer to 32, and then that would work out. But another way to do it is to use the algebra. The limit as x goes to -4 of x plus 4 over x cubed minus 16, that's going to be equal to whatever this is going to be algebraically equivalent to. So, or close to equivalent to, it's only going to disagree at -4 what you get. So it's going to be limit as x goes to -4 of, and this here, the bottom part, I could factor out an x. I'm going to be left with x squared minus 16, and then this factors as x plus 4 times x minus 4, and it's x plus 4 on the top. This cancels with this, and you're left with limit as x goes to -4, 1 over x times x minus 4. And now you see that as x goes towards -4, this bottom part doesn't even tend towards 0. This bottom part tends towards 32. And technically you know that this is a rational function, and a rational function is continuous on its domain. So this is just going to equal if I plug in -4 into this. Right? Because of the definition of continuity. If you know rational functions are continuous on their domain. But that's another discussion. But yeah, this top part is just staying fixed at 1, and as x goes towards -4 here, this is getting closer and closer to -4, and then this is getting closer and closer to -8. So the product is getting closer and closer to positive 32, and you get 32 again, whether you do L'Hopital's rule or you do the algebra in this case.